Okay, class, I'm going to work through an antiderivative for you today, okay? We're going to work this through, and we're going to try to explain it in the most complex, craziest way we can, okay? We're going to put the video on YouTube so everyone can see it and enjoy it. So maybe we'll make some money in addition to making where you can see it, because we have to do this for you. But the only thing is, you're not supposed to see me. All you're supposed to see is a piece of paper with writing appearing on there, and I'm talking in a monotone voice where we have to work the problem like this. Okay, so let's go up here and do this, because I want to do it fun. All right, class, now, to work this in the most complex way we can, we're going to go talking about this. And look, we have a sum of a function plus another, and then a difference. Okay? So we have to use the sum and difference rule when we do our antiderivatives. Okay? And that's going to make this turn into three antiderivatives. So we get to do more work and make it even more fun and exciting. All right? So let's break this up into three antiderivatives, shall we? So the first, my pen doesn't work. That's no fun. Let's get a new pen. Let's see, what color would be fun? Let's try this one. So we're going to break it up into an antiderivative of 5x to the fourth. Don't forget your dx. Because remember that dx stands for an infinitesimally small change in x. And it's only for x. So if that was dy, I couldn't do this. Okay? So you got to make sure you got that right. And then I'm going to put plus. And we're going to put an x cubed dx. And then a minus 2. And then we're going to have the 2 all by his lonely ass little self over here. Because he has to be by himself. All right, now, what else can we do to make this harder? All right, well, there's a rule. And if you look in the book and you look in my notes, there's like 15 different antiderivative rules. There's a sum rule, the difference rule, there's a multiplication rule. The multiplication rule says I can take the constants and put them in front. So now, class, we can put the 5 in front and have the x to the fourth dx. And see, I've isolated the x. Now he's all by himself like we're supposed to be doing at home. It's self-isolating. Okay? So we have the x self-isolated, so he's all happy and fun at home. All right? Now, what we're going to do next, oh wait, he's already isolated, so he's good. We're all happy with him. So we're just going to put him in here too. And the 2, well, we can take him outside like we did the 5 because, you know, the 2 and the x, they're not really good friends. We got to separate them. Or they're fighting, you know, they're throwing their juice cups at each other. It's all sorts of bad stuff, you know. We don't need any of that. So we'll get them apart from each other. All right, now what we're going to do next is we can do our antiderivatives. And remember, we have this equation right here that if I have a dx, the answer is ax plus c, and then if I have the antiderivative of x to the n dx, that is x to the n plus 1 over n plus 1 plus c. Okay? So we can apply this over here. You know, this is like rule 15, and over here is like rule 17. Somehow we're not using rule 16 today, but we'll find rule 16. Don't worry. It'll be in a later problem. Okay? So now we're going to apply both these rules. Right here, we have a kind of a mixture. I forgot rule 16. You know, rule 16 is if there's like a d in front of our antiderivative, you just leave it out front and you work the rule inside the parentheses. So we're going to have the 5 here, and we're going to work the rule here. So we have x to the 4 plus 1 over 4 plus 1. Okay? And then we have a plus c, because every single one has to have a plus c. All right? Over here, we're going to do the same thing, plus, we're going to add 1, so it's 3 plus 1 over 3 plus 1 plus c. And then over here, you know, we're matching this rule 15 up here. So we have minus 2, and we have to put an x in there because the x was missing. And one way to do this is you could think of this right here as if it was x to the 0. Okay? And this is a wonderful thing because x to 0 is easy to deal with. You know, we need to have it there. Because now I can do my rule, x to the 0 plus 1 over 0 plus 1 plus c. Oh wait, we got too many C's, so let's label them C1, C2, and C3. Okay? So now we got all of our C's. All right, now we're gonna go ahead and do the next step where we actually add some numbers together. You know it's math, we should be adding a few numbers, right? Because we're not adding numbers, we're not doing math. Wait, we're advanced math, we can add letters too, so just be aware of that. We're a little bit ahead. All right, so I've got 5x, 4 plus 1. Let me get my calculator and make sure what that is, okay? So we're going to hold my calculator correctly, and we're going to do 4 plus 1. Wait, you can't see that because all you have is a white piece of paper and my writing on it. Okay, but it's 5. So we have x to the 5th over 5. Okay? Now, don't forget your plus C1. Okay? And then we're going to do the same thing on the next one, so I get x to the 3 plus 1 is 4 over 4. And don't forget to add your C2, because we have lots of C's. It's like vitamin C. You need a lot of them to be healthy. Okay? And over here we're going to put the minus 2, and 0 plus 1 is 1 over 1. Don't forget that over 1. And then we have another plus C. Okay? All right, now, what do we do with all these C's? Well, they're constants, and you don't actually know what they are. But if I collect them all together, and let's do that next, so we'll have, I can cancel those 5s. So I have x to the 5th, and well, I'm going to leave this as 1/4 x to the 4th, and then minus 2x, because 2 divided by 1 is 1, so we can leave that. And then we have this plus C1, C2, and C3 at the end, okay? Now, C represents an arbitrary constant. We don't know what that number is, right? But what I can do with that, since I don't know what the number is, and I'm adding up a bunch of things I don't know what they are, I can just replace them with 1. And look, class, 15 minutes later, I have the answer to this problem. Okay? And there you go. That's how you work antiderivatives on YouTube.